Welcome to part 3 of the basic HAL tutorial for LinuxCNC. In this lesson I want to go over the setp, sets, and unlinkp commands and show you how you can use these within your HAL configuration to set parameters and pins, set signal values, and then for troubleshooting purposes use the unlinkp command to unlink values to either relink them to a different net command or just completely take them out of your HAL configuration on basically an as-needed basis. So what you can do when you have values already established and you have a machine loaded, if you go to the setting page, in the case of GMLKPi, there's a button in there called HAL Show. Click on that. You'll get the HAL configuration window, and inside of the HAL configuration window, at the very bottom of the Show tab, there's a line called Test HAL Command. And Test HAL Command is good for presetting parameters, pins, signals, unlinking values. Basically anything that you can do within a HAL configuration file, you could do in the Test HAL command. Now this is a non-destructive way of doing it, so you can make modifications to your HAL file in real time and test those before you commit to them in your HAL configuration file. So the first thing I want to go over is the setp command. And the setp command is for setting the values of pins or parameters within your HAL file. So think of setp as set pin or set parameter. The values that you put into the setp command are going to vary depending on the type of value you're changing, whether it is a pin or a parameter. If I go into my HAL configuration, on the left-hand side you'll see I have components, pins, parameters, signals, functions, and threads. Under the pin section, I've got a whole bunch of different categories that I can look at under the Show window or under the Watch window. In the case of classic ladder 0, float in 0, 0, float in 0, 0 has a value of 0. If I add that to my watch list and I scroll down to just basic input, we'll say 30. Classic ladder.0.in-30 has a value of false. I'm going to add that to my watch list. Same thing with output 30. I'll add that to the watch list. And I will add S32 in 0, 0. So right here I've got 4 different types of pin signals tied into my watch list. I've got 0 values for float, I've got an input, I've got an output, and I've got an S32 signal. Now the data types, not to venture off too far, but the data types are also listed within the basic HAL tutorial on the LinuxCNC website. And those data types are bit, float, S32, and U32. So to gloss over these briefly, a bit value is an on and off value or on or off value. It's true or false, or in the computer world, 0 or 1. If you're used to hearing about binary digits, 0 is off, 1 is on. So think of a bit value as just a light switch, either on or off. A float value is a floating point number with decimal capability. So you see right here, 64-bit floating point value with approximately 53 bits of resolution and over 1,000 bits of dynamic range. If you look at this Wikipedia link, you can see what floating numbers are. But basically, if you have a calculated value of, say, pi, 3.14. So 3.14 would be held or handled through HAL as a floating point value. Then you have S32 and U32, which are integer values. And integer values are non-decimal numbers. They're whole numbers that start off at 0. They go 1, 2, 3, 4. And in the case of S32, they go -1, -2, -3, -4, so on and so forth. But they don't have decimal point values, and they don't have any way of passing decimal points to them. The same thing goes with U32. Those are positive integer values from 0 to 42 gajillion, positive value only, not available as a negative value. So going back to what we were talking about, the setp command allows you to set the values of pins or parameters. So in my HAL configuration, I've got a couple of different values here. I've got a float, an in, an out, and S32. If I go to the show list and I go down here under test HAL command, I can use the test HAL command to test a value. I could set p. In this case, I want to do classic ladder .0 .float in -00. So classic ladder .0 .float in -00, and I want to set that to 2.2. You'll see up here that it accepted the value change, and if I go to the watch list, you'll see that that value is now 2.2. Because it's a floating decimal point value, I could set that to 2.215683910. And if I go to the watch list again, you'll see it right here. It does truncate it to the 6th place, but it does hold that value internally. If I set that to 2, it sets it to 2. If I set this to -43,598, oop, I missed the minus, -43,598.666. We go to our watch list. Again, we will see that the values here, it is truncated because of the available digits in the watch list window. But internally, it is set for that value. I could do a setp for classic ladder .0.in-30. Now here's where the bit values come in handy because, again, remember I said a bit value is true or false, or in computer language, 0 or 1. So I could say is true. And if I go to the watch list, you'll see that the little yellow light is on to say that it's true. I could say false, and it sets it to false. The light goes out. But also, I can use binary values. Is 1, is on, 0, is off. Now you can see that the output doesn't allow me to do a setp. If you get an error message in your HAL configuration, if you go to details, most of the time it will tell you why you have that error message. So this is very helpful when you're trying to troubleshoot something within your HAL file, because it's better to get this error here than to get the HAL or the LinuxCNC crash screen. then you have to go down to the debug file information and you have to find out what you did wrong there, as opposed to testing all of your values and settings here. And if you make a mistake, you just hit OK, you delete that, and no harm, no foul. So that's a little bit, that's a difference here. So again, if I wanted to do something, like let's say I wanted to try a net command. Say I do net hello fill, and I want to tie that to input.0.button C. So it took that, but if I want to net hello fill 2 to input.0.button C, you'll see that it comes up with an error message. And it'll say that it's already linked to signal hello fill, as opposed to hello fill 2. So again, this is a helpful little tool because as you're going through and making your changes to your HAL file, you may make a couple of changes and then you try to reload LinuxCNC and all you're getting is that crash screen over and over and over, and you're changing and you're changing and you're trying to find what you did wrong, as opposed to going through and testing the stuff here. And the nice thing about this is that once you set something that you like, inside of this window at the bottom here, you can drag it with your mouse, highlight it, and then use Control-C or Control-X to cut it. Then open up your HAL configuration and paste it into your HAL configuration. So I'm not gonna paste in a bunch of gibberish, but let me do a net test-button-1, and we'll link that to input.0.button B. And you can see right here, we have button B already linked to a signal called home all. So let's see if, okay, so button X is available. So I can take this, I can drag it, Control X to cut. I like cut because it's more positive than Control C. Control C, you don't really know if it copied or not. Control X, you know it cut it because it disappears. I'll go into my rant mill file, and I'll go under my custom post GUI HAL, and I can go down to somewhere at the bottom here, and I can take it, I can paste it in, and now when I reload LinuxCNC, after I save that file, I can close out, reload LinuxCNC, go back to my HAL show, and under signals, we'll see that I have test button 1, and test button 1 is linked to input.0.buttonX. So now let's do something a little bit different. This test button 1 is linked to a signal. Now signals you would change with the setS command. And the setS command is for, again, changing signals. It's for changing things that already have some sort of tie-in via the net command. So you have to be careful with signals because a lot of them will not let you change them because they're already tied to writers. And it says right inside of here, a setS command will give you an error if the signal name does not exist, if the signal already has a writer, or if the value is not the correct type for the signal. So if I go into, say, jog X pause, if I try to do a setS command to jog X pause, going to say it already has writers. The writers are the input hat button and the gmoccupy jog X plus pin. Now the probe input may or may not let me do it. So if I do set S probe in true, it already has a writer. So this is where the unlink kind of comes in, because I can do an unlinkp and say we're going to unlink it from parport.0.pin-13-in. And then we can click on it again, and we'll see that it's now missing one of the links. Here I should be able to do set S probe in true. Now that it's been unlinked from the parallel port pin, I can now add that to my watch list, and I can use the set S command to set it true, set it false, or set it 0 or 1, which will give me the same result. So 1 is yellow, 0 is false, or dark reddish brown, whatever you want to call that. If we want to get a little deeper with that probe in, we can totally unlink that. So I can unlink P motion.probe-input. And now if I try to do a set S probe in, it only gives me the signal value. It doesn't give me the motion.probe-in. For that I have to go to pins. I have to find motion, and then down to probe input, add that to the watch list, and we'll see right now that even though the signal of probe in is still valid, it doesn't have any tie-ins with motion.probe-input. So I'll set that to 0. We'll see that they're both off. But now I can go in and I can do a net command, and we'll say probe-in motion.probe-input, and that will relink the pin to the probe in signal. And you'll see right here that it's been relinked. So now if I do a set S probe in 1, you'll see that both the probe in signal and the motion.probe-input are true. So again, I'll do an unlink P motion.probe-input. I'll do a set P, because now if I do a set S probe in, it'll set the signal, but it doesn't set the pin. So to test the pin, I would use set P motion.input is 1. So now they're independent of one another. But at this point, if I wanted to, again, relink them together, net probe in motion.probe-input, and now they're happy again. So you can see that this HAL configuration window is a very powerful tool for testing your HAL configurations, for testing different things. You can also use the HAL configuration for creating components. So if I look in my component list right here, I have a not component, XOR2, OR2. It doesn't look like I have, okay, so I don't have a toggle. And toggle is going to be something that I want to cover in one of the future videos. There's actually two commands that I found very helpful in HAL that seem to be a little bit more difficult in Classic Ladder. And those two commands are the multi-switch command and the toggle command. So I want to load the multi-switch and I want to load toggle because I don't see either one of them on my component list. So under test HAL command I can do a load RT, so load real-time multi-switch. And if it already had it loaded, it would just say, hey, it's already loaded. So I could try it again and it'll just say multi-switch already exists. And then from there I want to do a load RT of toggle. Those are just two components that I have found to be very useful for making my hardware work, or making my hardware and software work the way that I want them to work. Once a component is loaded, you don't really see it on the list unless you close the HAL configuration and reload it. Once you do that, and you go to your component list, you'll see that toggle and multi-switch have been created. But now the thing with HAL components is that once you load them with load RT, you have to assign them to one of the available threads, the base thread or the servo thread, depending on how fast processing speed you need for those particular commands to take place. And in the case of toggle and multi-switch, servo thread is fine. So we would do an add f toggle.0 to servo thread. And the reason why we do a toggle.0 instead of just toggle is because when you create a component, it creates a pin, or a pin set really. And in the case of toggle, it'll be toggle 0 in, out, or time. So we have to load the specific pin set, in this case toggle.0, to the thread. Same thing with multi-switch. We could actually do, if I close this out, load it back up. When you close out and load up, when you're using HAL configuration, it will completely eliminate any of the changes that you've made to that HAL configuration. So again, you can see the benefit to this because you can do all kinds of testing before you commit to loading it into your HAL file. So again, we can see that the toggle and the multi-switch are missing. So I'm just going to reload those with load RT, toggle, and I'm going to say count equals 2. And then I'm going to say load RT, multi-switch, CFG equals 3, 5. Now you may be wondering what this stuff actually does, and we're going to cover this in an upcoming video because this is important to know. But for right now, I'm just going to reload my configuration to refresh it. So under my components, I have my multi-switch, I have my toggle. Under pins, not only will I have a toggle 0, but because I said that the count was 2, I have a 0 and I have a 1. So I've got two instances of toggle that I can use in my HAL configuration to toggle basically toggle an input button. So if you watch my classic ladder videos, the last video, or part 4, I don't know. I've been doing so many videos that I can't keep track. The most recent one that I did, I built a latching circuit. Basically what toggle does, it does the same thing. It takes an input value from a button and it either sets it true or false until you press it again, and then it sets it from false to true. So in this case here, I've got 2 instances of toggle that I can use. So I can assign 2 different buttons on my PlayStation controller as toggle buttons. Under multi-switch, that's going to be a little bit different, because multi-switch, you have not only a 0 and a 1, but you also have an available amount of bits for each multi-switch. So if you remember, I said 3 and 5 under that CFG. So I told it to make 2 instances, and the configuration of each one was 3 bits for multi-switch 0 and 5 bits for multi-switch 1. So for the most part, I've been going over all of the different commands that we can use within the HAL configuration inside of the HAL configuration window. I want to take a little sidestep into the world of a real HAL file and show you that the things that I was just doing, setp, sets, unlinkp, net, loadrt, and addf, those are all part of the actual HAL file. So everything that we test, again, we can copy and we can paste into our configuration once we know that it's right. So if we look here, we can see a setp that sets a power port value to 5000. Scrolling down a little further, we can see that there is a setp for a couple of PWM pins. And this is something that was helpful to me, because when I was debugging the PWM signal from my super PID going out to my G540, I had my HAL configuration window open, and I was changing the PWM gen.0.offset and the .0.scale and making minor adjustments while the machine was running, while the spindle was actually turning. I could go in and I could make changes to these pin values. So here I can copy this, paste it into here, and offset it by 10. It's a non-volatile change because I haven't changed it in the HAL file and made the commitment to it yet. But I could test this out, and I could see if my spindle value was closer to my program value or if it was further away. And then the same thing with the scale. You could go in, you can make changes to the scale. Anything that you see that has been netted, you can use an unlinkp. So I could take this spindle.0.speed out. I could put that into here. And I've just unlinked that from the HAL file, the spindle-cmd-rpm. I unlinked that in the HAL configuration, but I haven't made a destructive change to the actual HAL file. So you can see where the two kind of play nice with one another. And you can use this to, again, change values inside of here. If you need to make a slight adjustment to, basically anything that you see here that has a set P, you can go in and make changes to inside of HAL configuration and not mess up your HAL file to a point where you have to reinitialize your entire machine. So again, very helpful tool. So learn to grab the, learn to take control and harness the power of that HAL configuration window to make you a better HAL configurer, for lack of better terms. So that concludes my lesson tonight. Again, please be sure to like and subscribe. If you have any suggestions for future videos, please let me know in the comments below, and we will see you soon. Thanks for watching.